Solving quadratic equations using square roots. The square root property that if x squared equals a for when a is greater than or equal to 0, then x equals the square root of a, so a positive, or x equals the negative square root of that a. And you're always look to see if you can simplify the radical first. Now you'll see that there's going to be many ways to solve a quadratic equation, but what's specific about this one is that there's always just an x squared. Like there's no other terms dealing with a variable, it's just that one. So in this case, to get rid of this x squared and find out what this equals, we're going to take the square root of both sides. So that's the inverse operation. So it's going to be x equals, now when you take the square root of both sides, it's really saying that you have two solutions. So the square root of 9 can be plus or minus the square root of, or plus or minus 3. If you think about it, if I put 3 back into my equation, 3 squared equals 9, and negative 3 squared equals 9. So that's why there's two solutions for that. In this one, again, we want to get x by itself. So we're trying to solve for x. I'm going to add 54 on both sides to get x by itself. So I have 3x squared equals 54. I still have to get x by itself, so this is multiplication between the 3 and the x squared, so I'm going to divide by 3. And I'm going to get x squared equals 18. To get rid of that squared, I always do the inverse operation, so I'm going to take the square root of both sides. But I noticed that the square root of 18 is actually not a perfect square value. So I'm going to simplify it down to the furthest radical that I can go. So I would take out a perfect square of 9, and 9 times 2 gives me 18. So I'm going to get x equals plus or minus 3 square root 2. So that means that if I put in a positive 3 square root 2 into this x squared, I will get 0. And also if I do a negative 3 square root 2 squared times 3, I'll get 0. This one I'm still solving for x squared, so I'm going to subtract 34 on both sides. So I'm going to get 2x squared equals 64. I'm going to divide by 2, so I get x squared equals 32. I'm going to get rid of that squared, so I'm going to take the square root of both sides. So I get x equals, now I know that the square root of 32 I cannot take, it's not a perfect square, but I can take a perfect square out. And in this case, I could take out a 4, but it would be 4 times 8, and 8 could be simplified more, so the highest, greatest perfect square value I can take out is 16. So I got the square root of 16 times the square root of 2. I have x equals, I'm going to have plus or minus 4 square root 2. That would be my final answer. Now, to get x squared by itself, I'm going to divide by 2 on both sides. And I get x squared equals 7 over 2. If I take the square root of both sides, I notice that this is a fraction. So I really have x equals the square root of 7 over the square root of 2. I cannot have a radical in the denominator, so how to get rid of that is to multiply by the radical in the denominator. So I have 7 times 2, which is going to give me the square root of 14, over 2 times 2 is the square root of 4. Square root of 4 is 2. So my final answer is going to be x equals plus or minus the square root 14 over 2. That would be my final answer, because I can't simplify the square root of 14 any further. Now this last one, if I divide by 49 on both sides to get x squared by itself, I have x squared equals, I'm going to have 16 over 49. If I take the square root of both sides to get rid of that squared, what's happening is I would be taking the square root of 16 and the square root of 49. Square root of 16 is 4, so I have plus or minus 4 over the square root of 49 is 7. So my final answers are plus or minus the 4 divided by 7.